All right, now we have several, 3 or 4 different kinds of tests, and so I'd like to do some examples where I ask about specific tests for divergence or convergence. And so first, this one, summation n equals 1 to infinity, 3n squared divided by n squared plus 1. So these are very good test questions. I could ask all three about one series. What does the geometric series test say? Well, you look at it and it does not look like a geometric series. A geometric series has to be a real number, r, to the power n, the same index that is underneath. That's not happening. This is n squared. So this does not apply. You can look at what the geometric series has to look like, compare it to that. Doesn't look like it at all. You can do algebra on a series in order to make it fit the application, but by this, I mean there is no algebra that turns this into r to the n inside there. You need an r to the n for the geometric series test to apply. Now, how about the p-series? Same problem. P-series does not apply. Put a box around that. Because it's not equal to 1 over n to the p. It's closer to that. It has n squared, which is almost 1 over n to the p, but it also has n squared on the numerator on the top. And there's no way to cancel in order to get it to look like 1 over n to the p. No algebra can do that, so it does not apply. Finally, we get the limit test for divergence. What does the limit test for divergence say? All right, so for this, I need to actually do some work, because I look at the chart, and that applies to any function at all. So it does apply, but I need to see what it says. All right, so I take the limit as n goes to infinity of the terms of that series, 3n squared over n squared plus 1. I take the limit of the sequence instead of the series. I replace the summation with limit. And that's a limit I know how to do. You can use either L'Hopital's rule or just the rule about rational functions top to bottom. If they have the same power, the same degree, the same highest power, you can just take the coefficients. So that limit comes out to 30. And of course, when I take the limit, I'm thinking of it as a value that is x, continuous value, but n is fine here. You can just replace the n with an x in your mind if you wish. And as you go to infinity, it's the same thing. So you get an answer 3 there. So the limit test for divergence, remember, says that if you get a number that is not 0, then it diverges. That's because the terms in that sequence are becoming closer and closer to 3, and you're adding them up forever, like we said in the notes earlier when we talked about this limit test. If you add them up forever, and you're adding up something that looks like 3 or close to it forever, you're adding 3 plus 3 plus 3 plus 3 plus 3, that goes to infinity, so it diverges. All right, here's another one. Similar 3 questions. This example is summation n equals 1 to infinity of 1 over n to the 4. All right, so that one's easier. I kind of know what it is, but let's ask all 3 questions because it might on the test. What does the limit test for divergence say? Well, that applies to every single function, so I have to go ahead and do it. Limit as n goes to infinity, 1 over n to the 4. That's that's a rational function. It has a degree 0 on top, just the 1, and a degree 4 on the bottom. So that goes to 0. Has much bigger on the bottom than on top. It's like 1 over infinity. So it goes to 0. But if the limit goes to 0, that is inconclusive. Does not tell me anything. So the answer to this would be inconclusive. There's sometimes the limit goes to 0 and you get that the series diverges. Sometimes the limit goes to 0 and you get that the series converges. So we'd have to go on. It's sort of like what would happen in real life if you're working on this. You don't know which test you would apply. So on an exam, I could ask you about several of them and you have to tell me what they tell you. Do they tell you something or not? In this case, inconclusive. The second one is, what does the geometric series test say? So this one is going to be a does not apply. That's not a geometric series test because it's not a real number to an n, like r to the n. Instead, it's n to the 4. So it's a p-series, looking ahead a bit. So the answer to this one is does not apply again. It's not equal to r to the n. But it is going to be a p-series. P-series, it does apply. It looks exactly like 1 over n to the p. And in this case, the answer is going to be really nice. It does apply. P equals 4, which is greater than 1. So whenever you get a p-series and the p value is greater than 1, that's the power that's on n, then it converges. Now remember that this was, for the p-series, we don't get a nice formula like we did for the geometric series. It's an open question what it might converge to. People have figured out answers for a lot of them, and then it's very closely related to the Riemann hypothesis, which basically first lets you use imaginary numbers, complex numbers, instead of just real numbers, and second asks, when does that turn out to give you a convergence to 0? And I'll put some links to that on there if anybody's curious about the Riemann hypothesis, which if you ever solved it, you could earn $1 million. But for us, all we need to know is if p-series for real numbers has a power that's bigger than 1, then it converges. If it was smaller than or equal to 1, it would diverge.